Good day to everyone. We will be discussing for today business software part one. For business hardware that is actually tackled already, please revisit the two parts of that as well. Now, objectives for the first part would be to explain the difference between application software and system software. And then we have to enumerate the different generations of programming languages, since there are ways and there are actually certain formats and words or terms that we have to use should we do programming. That is IT aspect, but for us it's not. Then we have to explain how they differ or how do these languages differ. Next will be to cite the latest major developments in application and system software, which are the two types of the softwares. Then identify and explain the roles of web programming languages. There are languages as to we create programs, and they're also specifically on programs for the web. Then for the second part, we are going to discuss about the types and uses of website design tools, differences between proprietary software and open source, characteristics that are important in evaluating packaged software applications for business use will have to be listed, and all about software piracy and how it affects businesses and consumers. So we have to explain such. To formally begin, we have software as being started. So basically software is that intangible component of our computer operations as opposed to hardware that is physical component, or these are the physical components. Software is intangible aspects, and normally these are instructions to be provided to the hardware so that the desired outputs will be generated. And here are our terms, definition of terms. Applications, these are computers programs that contribute to productivity, and also these are softwares. Software is a series of instructions to a computer to execute processes. If, for example, we have Microsoft Word as an application software, so for example, we are going to do keyboard shortcuts or simply clicking certain menus there. Those particular series of options, if to be done or steps to be done, will produce the output. Prior to that, of course, we'll execute the processes to produce the output. There are two major categories of software. We have application, which focuses on enabling task completion, and system, which enables applications to run on a computer. So example will be the operating system or OS. And then by that OS, certain applications can now be installed on the system to be able to do certain instructions and applications. Then these also manages components and devices. For Microsoft, of course, we have our Microsoft OSs, but for Apple, we have the Apple iOS. So different strokes for different folks and different companies, of course. Then we have programming languages and software development tools. Programs are needed for every computer operation. It's like when we are going to click or enter, for example, then that program will just run and will process and produce the output. Programming is the process of writing programs. Somehow, again, not on our end as business practitioners and prior to that as learners and students, but at least we can have a soft understanding of how it works. And normally it begins with machine language, that the only language hardware understands, consists of long strings of zeros and ones. Another one would be assembly language, which is easier to program than machine language because it uses words for commands as opposed to zeros and ones. And finally, high-level programming languages that would use English-like statements. And that is our target normally. The software development tools would develop software with little knowledge of programming languages. We also have 3GLs as procedural languages that programmer must detail logical procedure. And these are some examples of languages. As for me, I've experienced before C. So just like short undergoing of the certain programming aspects, but there are so many. I understand that we have COBOL, Fortran, Basic, RPG, Pascal, and again, we tried C before. One 3GL statement is equal to 5 to 10 assembly language statements. As a review, assembly language again would use words for commands. 4GLs, on another hand, is our high-level programming languages, which will use more English-like statements that would speed up the development process, would build around DBMSS database or repository of information, would include many pre-programmed procedures. So if we just have to click or enter certain command, then the program will just run. One 4GL statement equals several 3GL statements. So words from here, of course, would become to sentences. And that's normal that the sentence would be composed of a lot of words. If there will be some problems or program errors, debugging will do the work. That's the process of locating and fixing program errors. This is the evolution of programming languages from first 1940s, that's machine, 1950s assembly, third generation 1950s, fourth generation 1980s, also with 1990s to 2000s, and the human language in the future. Use natural language and no need to learn new syntax or no need to learn certain programming languages, which are, for example, just words or incomplete sentences or thoughts. For first generation, that's the problem. Difficult to learn and use long instructions, and machines can only read them. So machine dependent. For assembly, I said we use words, shorter codes, and machine dependent still. For third generation, English-like, problem-oriented, easier to learn and use as compared to the prior two. For fourth generation in 1980s, more English-like, many pre-programmed functions as explained a while ago, easy to learn and use. So we just have to focus with the last two, 1990s to 2000s with OOP, object-oriented programming, visual programming tools, and for the human language as well. For advantages and disadvantages of higher programming languages or level of that or those in figure 5-2, advantages would be ease of learning the language, programming, shorter code, of course, significant. Debugging is easy, and as well as the maintenance. For example, modification of a procedure. Disadvantages of higher level programming would be the less control because there's ease on learning the language. So in that case, more people can have access to certain devices, of course, given the fact that they have ways of accessing, and then they can also feed instructions to our hardware. So that's the counter aspect of having higher level programming, but can be solved by other ways. Less efficient memory use. There could be many files saved, and programs run more slowly, or program runs more slowly in that case, since there are already certain many features and files being placed. Next, visual programming languages would create graphical screen objects by selecting icons from a palette. And these are our examples of the VPLs. Then developer can still work at the code level. As for us guys, because we are business practitioners, so we're just doing again the soft run through of these particular softwares and aspects. For visual basic programmers, we can see here how the elements they develop on the left side will look in the final application. So example, there are basically making a question, choose one of the following. So this is how it looks like now under, for example, almost close to the final output. OOP is a modular approach to programming. So basically the overall broad and many aspects of certain programming languages and levels will have to be subdivided or separated into modules so that it will be easier to maintain and there can be efficiency in application development. Because when we are going to develop softwares, normally the challenges would be how we are going to make use of our resources to achieve our objectives, but we want the resources to be minimized to certain levels or results. Then for the object, this would contain data elements, data members, and the methods to manipulate that data. Data members can only be accessed through the object's methods. So this is one thing that we should remember about this. All right. For OOP also to continue, they're reusable. I'm talking about the objects, and they can be combined to create complex programs. Here are some popular OOP languages: Smalltalk, C++, Object Pascal, and Java. There has been increasing amount of software developed for the web. So this is now the web-based programming using these languages. Applet is a code produced by a web programming language. It runs same way on different OSs. Advantages of OOP would be lesser code than other languages, lesser time programming versus other languages. It enhances program modularity and reusability, because of course, the program is divided into a lot of modules and then it can be reused and recycled, as said here, to combine and create complex or complicated programs. This would make code maintenance easier, actually, and we can create user-friendly interface. So the applications that we can see on the screens would be friendly to us, as well as the experience that we will have in using such. This is appropriate for graphic and sound enhanced applications. For language translation, we have compilers and interpreters to do the work. Source code is a program as originally written by the developer. This is where we can see the original program. Object code, program in machine language that can be run by the computer. So this is after the source. Procedural languages need programs to translate source code to object code. So in fact, source code and object code are already programs. And to be able to convert from source to object, program is also needed. So anything that can produce certain output as used, series of instructions and steps, we call that a program, of course. Two types of language translators: compilers and interpreters. A compiler translates entire source code to object code, but does not execute the code. So simple translation. This can scan for syntax errors and generates error messages if syntax errors are found. Another one is interpreter. This scans one statement at a time. If error-free, interprets and executes the statement. This is now the action that is done after the compiler. Goes through the program until an error or end of program is encountered. And this is an illustration showing us about compilers and interpreters. A compiler converts higher level language code, the source code, into machine language object code. And this, in turn, the computer will now process. So this is how it actually looks like for source code compiler, and then compiler, remember, will convert such but not execute, and then we have the object code as discussed here and prior. Then interpreter can also do the job after that. For application software, they allow non-programmers to develop their own tools. We have application-specific, and general-purpose application software. For application-specific, clearly that will perform specific jobs. General-purpose can perform a lot and multiple purposes, like the packaged softwares. And these packaged softwares are normally the commercial ones, meaning to say that they can be bought, they can be purchased and acquired from certain suppliers and stores and vendors, and they're already available and readily made to be used. So example, again, the Microsoft Office applications, Microsoft Word, Excel, PowerPoint, etc. Software that is ready to install from external storage media such as CDs, for example. So the CDs would contain the information and the apps and would be downloaded to the computers, and such can now be used for certain purposes or goals. Then office productivity applications would assist us in our normal office work, as said a while ago, the Microsoft Office tools. Word processors like Microsoft Word, we can, of course, type and create documents, especially in text forms and formats like letters for business perspectives, reports, financial statements, and the likes. Spreadsheets can perform mathematical operations, whether easy and complex, also statistical and financial analysis. Then presentation tools, example would be Microsoft PowerPoint, wherein it's already built in for designs and animation and all, provided we can, of course, make use of such functions. We are knowledgeable of that, but basic ones can be done, still impressive though, and we can just edit the files or templates that are already there. Then file or database management tools would create and manipulate local or shared databases. We can store certain files and we can check them out. Graphics programs would be able to help us or can help us in making intricate graphical images and manipulate digital photographs. Example would be the Adobe Photoshop, wherein we can, of course, create some images if we would like to even drawing. For desktop or desktop publishing tools, these are used for making certain materials and articles in newspapers, magazines, and the like, such as pamphlets, newsletters, cards, calendars, and etc. There are also templates on desktop publishing tools. Then, as continued, we also have the project management tools. Actually, these are available but not that used, especially on certain levels, because they are not required to be used. But Word, Excel, PowerPoint, these are the three that are commonly used. Now, the suite is a collection of various applicants that perform multiple interrelated functions. Example would be the Microsoft Office, the Lotus Smart Suite, OpenOffice.org, and Think Free. For Microsoft Office, we have again our Microsoft Word, Excel, PowerPoint, Outlook, and the likes. OpenOffice.org, this is normally the same format and set of apps of Microsoft Office, just coming from other company or entity. So the rest will be experienced by us as we go along the way. But not everyone will have the experience, of course. Then Hypermedia. This is a feature that enables users to access information by clicking text or graphics. For example, if we just have to click a certain picture, then we will be forwarded to a certain information contained in a certain area, or we'll be able to access such particular file or information. Web page authoring tools enable hypermedia features. This is often part of other applications such as word processors and presentation tools. So we can make documents and can be linked to other parts. I recall, for example, PowerPoint presentations wherein there are certain pictures, and if we click that, that will be linked, for example, and that will be forwarded, or we will be forwarded to a certain file like music file or any other file being connected. And finally, for first part, we have the multimedia software that would handle many different types of data. They're often used in a lot of fields like education. So lessons presented in multimedia. So let's say in the form of audio, and then there's visual and more. Also for training exercises, when we train, let's say our employees or subordinates or agents, especially nowadays that we are in the modern technological age, and the more that we had the pandemic, we're in not allowed to stay in groups. So of course, we have our learning platforms that are ready, as well as certain virtual classrooms like, for example, Zoom and Google Meet, wherein we can discuss things. And finally, compiling and integrating data for business situations. So there would be some particular business experiences that will be compiled and then studied and reviewed to come up with certain learnings and important points, and will be carried forward, will be incorporated as part of the business processes and situations, so that as much as possible we can minimize the impact, or we can minimize the chances of such things happening. All right. So thank you very much for listening to our first part of business software. Make sure to watch out for the second part, and God bless us all.